And the leading hypothesis to explain this is known as the thrifty genotype hypothesis. And the idea with this is that ancestrally, we may have evolved in an environment where we were subject to periodic periods of famine and periodic periods of feast. During the periods of famine, we used up all the resources that we had, and we had a lot of physical activity to try to gather enough food. But then when we have a period of feast, then our bodies would have been adapted to make the best of the plentiful resources at that time and store them in different kinds of tissues, fatty tissues, for instance, so that the next time we are faced with famine, we can survive that period until we have, again, resources. So our genomes may have accumulated all sorts of genes that make it for very efficient utilization of food and storage. But now, in modern times, when we are faced with plentiful supply of food, we no longer have these periods of famine. These thrifty genes may actually be a problem for us because we accumulate all the food that we are eating with very little physical activity, and now we start to accumulate triglycerides and just fatty tissues without using them up either with exercise or with periods when we don't have food, and this results in the development of these diseases of civilization like diabetes, obesity, and cardiovascular disease. Now, the explanation for why there may be some variability among these different populations, proposed by Jared Diamond in a paper he published in 2003, may be that some populations, like Europeans perhaps, may have been exposed to periods of plentiful supply of food for a longer time than the other populations, and they may have already eliminated from their genomes these thrifty genes. But other populations that are, until very recently, have been exposed to these periods where they didn't have much food to eat, now that they are all of a sudden exposed to a lot of food, then they are expressing these thrifty genes that turn out to sort of express themselves in diseases like diabetes. And in the case of these islanders here, they underwent a change in lifestyle, they became very wealthy, and that's when their thrifty genes became expressed. And the final example has to do with allergies and asthma that have also increased in recent times. Asthma, for instance, was almost unknown 30 years ago, but today between 20 and 30% of the population in some countries may have asthma. And again, there is a very attractive hypothesis to explain why this may be the case, and this is known as the hygiene hypothesis. And basically, this hypothesis suggests that we may be exposed to too few germs and parasites, and as a result of that, because we are just too clean, and as a result of that, our immune system doesn't develop properly, and we start to respond inappropriately to harmless substances, and we develop allergies. And there is all different lines of research that support this hypothesis. And just some patterns here, for instance, allergies are less common in the developing world. They are less common among children that grow up in farms, and they are also less common in children that have a greater number of elder siblings, with the idea that these younger children with older siblings would be more likely to be exposed to infections. Also, allergies and asthma are not more common in cities that are polluted. So contrary to popular belief, pollution doesn't really have much to do with asthma. And we are still working out what may be the mechanisms that sort of relate hygiene with allergies. But my favorite hypothesis related to this has to do with parasitic worms. It turns out that the immune response that is involved in allergies is the same response that our bodies use to rid ourselves from parasites, from parasitic worms. And the idea here is that the worms, and there is data showing this, they also fight back. We are trying to eliminate them with this immune response, and they fight back by producing substances that suppress this response. So if we have worms in our bodies, then we are protected from allergies. But if we don't have any more worms in our bodies, then our bodies are going to start sort of manifesting these allergies. So there is actually some data to show this pattern. For instance, in a study done in Venezuela, looking at populations of different socioeconomic levels. So people of high socioeconomic level have very little in the form of parasitic infections, but have a very high incidence of allergies, while people in rural areas or Aboriginal people have very high infestation of parasitic worms, but they have almost no allergies whatsoever or very little allergies. So there's clearly a correlation here between worm infestation and the presence or absence of allergies.
Are the allergic people just dead already?
No, they really don't have allergies there. So some researchers have actually taken this idea seriously, and they are investigating whether we could actually use worms to protect ourselves from allergies. And so there is a study underway at the University of Nottingham where they have actually looked into infecting people with worms and seeing whether that protects them from allergies. So this study had two phases. The first one already was completed. Some volunteers, and most of these volunteers were actually the researchers themselves. They infected themselves with different numbers of worms, and what they used is a hookworm, and I'm going to show you that in a minute, how those worms look like. They infected themselves with worms to decide how many is not too many, and they decided that 10 worms is good. Then they infected some volunteers that exhibit bad cases of allergies with these 10 hookworms, and see whether they actually were protected from allergies. And these volunteers, the ones that participated in the hay fever study, the last thing I read about it is that they were supposed to be dewormed at the end of the study, but they decided not to, because they really felt a definite improvement in their allergy symptoms. And it turns out that these worms may not only protect them from allergies and asthma, but they also may serve as a protection against autoimmune disorders that have a similar relationship to our bodies. And so the worm that they use for these studies is the hookworm. And I show you what these worms look like and what they do. So they are not necessarily very attractive. Here's a little picture of the head of these worms. But they are actually not that harmful. And what they do is they live inside our intestine, and then they mate with each other there, and their eggs are actually discharged in the feces, and then they go in the soil. And the way people get infected by them is that when they walk on contaminated soil, then the larvae of these worms, they crawl into their skin, and this is not very pretty. They go through your skin, they travel to the lungs, then they go from the trachea, they climb into the esophagus, and then they go to the intestine. So it is apparently not really pleasant when you go through this, but once they are in the intestine, they are not going to reproduce within our body. So if you get infected with 10 worms, that's what you get, 10 worms. And you're not going to have any increase in population of worms within you. And in preparation for this talk, I actually found a blog of somebody who suffered from very bad allergies and had heard about this, and then he did a lot of research about this. And he went about trying to figure out how he could get himself infected with these worms. He tried to participate in the study at the University of Nottingham, and he wasn't able to. He rode around the world seeing whether there were any labs that could give him the worms, and nobody had them. So he went to Africa. And on purpose, he walked barefoot in places where he thought he would get contaminated with the worms. And he succeeded at getting contaminated with the worms. And this is what he says. Because although it sounds strange and it's repellent, it is founded on sound science, and it has one other virtue. It worked. So he is definitely basically cured of his allergies by being contaminated with these worms. And because these worms don't live for a very long time, what he's doing is continuously reinfecting himself every year with the worms, the eggs of the worms that come out of himself every year, so that he maintains this constant supply of worms. So if you are curious about this, you can email me, or you can, I know it's a bit hard to take this website, but that is a possibility. So this is another example to illustrate how, when we consider the environments in which we evolve, we can sort of better understand why we are built the way we are, why we get sick the way we get sick, and we can develop better strategies to fight disease. Now, in the case of the worms, of course, the idea eventually is going to be to figure out what kind of substances the worms produce, so that we can make some medicine that causes the same effects that the worms are doing in our bodies. So with that, I just like to also... Oh, yeah. So it is really easy to get rid of the worms. You just take some medicine to deworm yourself. So it just takes a couple of days, so it's not a problem. Okay, so with that, I just like to sort of, if you have really bad allergies or autoimmune disorders, you choose which would you rather have. And with that, I just like to thank you very much for your attention. And just with these examples, hopefully you will be convinced that evolutionary medicine, that evolution should be incorporated in the medical school curriculum because it's going to improve the medicine that we do. Thank you.